Hello and welcome back to my channel. My name is Okwemi and I create content about software development. Today we're going to be talking about Git and GitHub. It's alright if you don't know what Git or GitHub is. I've provided a helpful link, tutorial or guide in the description where you can go and read it. Alright, so this is just the demonstration part in this video, right? So before I actually begin, I have to also mention that I assumed you've already installed Git on your machine. If not, go on the guide to show you how. Okay, and yeah, and well, also one more thing, we're going to be using Visual Studio Code. Also install that Visual Studio Code. Just Google it and download it, and we'll be fine. So cheers. So there are two parts to this video. The first part is actually using Git with as a new project on a new project, and the second part will be using Git for an existing project. So we'll start with using Git with a new project. Okay. So what I mean using Git with a new project, it means you are the creator of a software. Now you want to use Git on that software, okay? Now, I need to mention that this tutorial does not require you to have any experience, any coding experience, because I'm going to make it so simple, you're going to know it, okay? There's no coding required. Before was that I assumed you've already installed Git. I know you already installed Visual Studio. So to install Visual Studio is not hard. There's no complicated process. Okay, you just install it. Okay. So now I'm going to open up my terminal, right? So what is terminal? So if you're on Windows, you might need to open what's called Git Bash. Okay. So yeah, right. So to confirm that I have Git installed, I'm just going to do Git dash version, and you're going to see it's already installed. So terminal is an interface for interacting with your computer system directly. All right, so Git is a software, all right, but it's a software that is operated through the command line interface. Okay, right. So as you can see here, we have the Git version 2.37.1. So yeah, install. Next up, I'm going to bring up Visual Studio Code. Open Visual Studio Code while keeping this running, while keeping the terminal open, right? So I'm just going to open my Visual Studio Code, right? It's similar process if you're on other system, just open Visual Studio Code. And now let's assume I want to, I said there are two parts, right? So this is the part where I am creating a project from scratch, okay? And of course, let's say a new project is going to be called, I'm just going to call it software project, okay? I'm just going to create a new folder, and this folder will contain our project. I'm going to call it software project, okay? Right, so whatever is within this folder now contains our code, okay? Assume that's our code. Okay, let's assume we have two files, all right? Let's assume we have two files, and because no software development experience is required, I'm just going to make them text documents, okay? And let's call them document 1 and document 2, okay? So come in your Visual Studio Code, click on this, or alternatively just right click and click on new file. So I'm just going to click on name it doc1.txt, okay? And right, I'm just going to write hello world here, okay? I'm going to save it, and I'm going to create a new file. I'm going to call it doc2, okay, .txt, and I'm going to write, this is a random text here, okay? This is a random text. So for the sake of argument, assume this was your code, right? Assume this was your code. And this is your project, right? And now I'm just going to close this welcome tab. And now assume, now how do you get it on Git, right? How do you get it on Git? It's really simple. Where the file where the software, your software project is, right? The folder, which is this one where we're working on, you drag it in your Git Bash or terminal, okay, whatever you're using, and you automatically get the path. I know if you're on Windows, you can copy the path, but because I'm a Mac, that's a bit tricky. So now I want to go to this directory on my terminal. That's why I'm doing this. So what I'm doing here is, now I'm in this folder, right? So if I type in the command ls-a, you can see it contains our files, doc1, let me close this. It contains doc1 and doc2, as you can see here. Ignore this dots, but these are what I'm talking about, okay? Now, how do you add Git to this project? All right, so what you need to do, once you're in the root folder of your software project, what you need to do is type in git init in your terminal, okay? And that will initialize Git. And as you can see, it told me it has successfully initialized Git. Is initialized. One thing I did forget to mention at the beginning of this video is the first thing you do when you've installed Git on your machine, all right, is to set up your config files, your username, your name, and your email address. This is really important because remember, the point of Git and GitHub is to, number one, track files. And to do that, you have to know, number one, to track files, and number one, to collaborate. So if in order to do that, you have to know the details of who's doing what. So it's really important. So to do that, you have to do git config, right, -- global, okay, and write user.name, all right. Then you put in your quotation marks here and you write your name. For example, my name is this, all right, and I've put in my email address. So it's really important you do this. If not, you know, you will be causing confusion when you're collaborating with other people, right? So this is just for a later scenario. So you do the same thing for your name, for your email address. So instead of user.name, it's user.email, right? So instead of this, instead of what's here, you write your email address, xyz@gmail.com, whatever it is. So yeah, I already done that, so there's no need for me to do it again. Writing your name or your name or your email address, you can do it as many times as you like. And if you want to check, if you're not sure, if you want to check whether you write it right or wrong, what you write is, you want to see is config -- list, and it will write if I click on, if I hit enter now, I'll see my details. You see name and other config files, all right? So if you're not sure, you can check there, okay? So we are going to move on. Now, we have initialized Git in our project. Now, as you can see, because Visual Studio is a very smart IDE, it has, if you come under here, you can see it has shown that this is now under version control, okay? Great. So the first thing we need to learn in Git is the file within the Git system. So, and they're basically to track and untrack. And as the name suggests, track simply means Git tracks whatever happens within that document. Untrack means Git does not. As of right now, Git does not track any changes. So let me just type in git status. You're going to be seeing this command for the first time. As you can see, of course, Git is already initialized, right? The repository is initialized, but it's telling us that these documents exist within within what I'm looking at, but they are not tracked. Whatever happens within this document, I don't know about it, right? So if I do this and I come, okay, let me save it first. And if I write git status, it's still telling me, you know, let me clear this one more time and show you. I do git status. As you can see, nothing happens. It's not tracked. So let me, yep. So now how do we track them? So it's simple. You do git add, and you can add individual file names, but instead you just use dot to add all of them, okay? And now if I do git status, it's telling me that I've added all of the files, okay? I've added these files. As you can see here, it says new file, right? It means I've just added them to be tracked. Now, if I made a modification here and I say ABC, I save it, and I do git status, it's telling me, you know, as you can see, it's now tracked, okay? Let me do this, let me repeat the same for doc2, and I say XYZ, and save it, git status, as you can see, it's also tracked. So that's it. Successfully seen how to track changes within a document using Git, right? The point of Git is to track code changes, but in order to do that, it needs snapshot. All right, think of it as a picture, okay? For example, you go to Paris, you stand in front of the Eiffel Tower and you take a picture. That picture is an evidence that of where you were or what you were doing or your state at a particular point in time of your life. So the same is true for Git. When you're saving your document or your software project to Git, you're saying, Git, here's a snapshot of my project. I'm satisfied with this, all right? In more technical terms, we don't call it saving, we call it committing, all right? When you commit your document to Git, you're saying that's a snapshot. And you typically do this when you've reached a milestone within your project, which means you've fixed a particular bug, or you've added features, or you've done something you're satisfied with that you're happy to move with the project forward. Commit a file, we need to stage it. So what is staging? Now, we've looked at previously the two fundamental life cycle of files within Git. This is on track and track. But under track, the file can have three other stages, which is unmodified, modified, and staged. Unmodified and modified, we've looked at that. When the file is unmodified, Git status does not return anything. But the file is modified, we see what we see before. We see red in red. This file is modified. Now, stage is an important stage because it can be likened to taking a pose. Okay, when I take a pose, is your cue to take a picture. Okay, the same is true. Every file that is under stage is the file that's what snapshot it will be taken. So just because you modify a file does not mean it's a stage. Just because you take a pose does not mean your picture will be taken. The concept of staged and modified is really important when you're working on a large project, because some changes you don't want them to be captured. If you're working with two documents and you're making changes to one, and you're making changes to one because you just want to test it out, but you're tracking it so that you can remove it later, but you're working on another document B, which you have made changes that you really want to capture. So this really is important. You have to explicitly tell Git that this is what I want captured in my next commit. How do we actually stage our document for capturing or for committing? It's simple. We've seen this command before, and it's git add dot, which means to add everything to the stage directory. So if you want to add only git document 1 to the stage directory, we can do doc1.txt. okay, and that means if I type in git status now, right, recall I'm only interested in committing changes I made to document 1 to Git. So now we've staged it. Okay, now let's commit it. Now let's take a picture, let's take a snapshot. And to do that, you do git commit and you do flag M, which is for message, and you write what you've done within your code. Okay, for now I'm just going to write first commit, but when you're working on a large project, this is where you describe what you've done in your particular software. Okay, git commit. All right, we have successfully committed our file to Git. To see what the history of our commits, okay, of course now we have only one. You can just type in git log -- one line. As you can see, our first commit is there. Now recall, we only committed changes we made to document 1. Document 2 still remains under modified. Okay, so now if we were to, let's say, git reset -- what's it now, git reset head, no, hard, and type in head. Right, so if we now go back to our project, you can see the changes we made to document 2 have been removed. Instead of manually removing all the changes we make to the documents, the ones we temporarily don't need, you can do that and everything would be gone. Okay, as you can see here, we had XYZ before down here, and now it's gone. In summary, the git command written up there, git reset -- hard head, all it does is return your code to your last commit and removes any other changes. Okay, now I've gone ahead to add new lines to our document, a new random line in doc2 and a new and lorem ipsum in doc1. Now it's a constant play of adding moving between the modified and the staged directory. So now in my next commit, I want to make sure everything is added and is staged for committing, and I say git add. Okay, and I now say git commit second commit. Oh yeah, I need the flag M. Okay, yeah, second commit. Okay, and if I do git log -one line, okay, as you can see, it's telling us this is already committed. Do git reset now. Of course, if I go back into my code, nothing changes because everything has been committed and there's nothing that was removed. Every save that I made was saved, as you can see in the document over here. Okay, lorem ipsum is here and a new random line is here. To recap, let me make one more change to my document and go through the procedure. So I'm just going to come here and say final, okay, final doc1. Okay, just don't mind me, I'm just going to say hello. Okay, I'm going to say hello. I'm going to save it. Okay. Oh, yeah. I'm going to save it. Come to my Git and Git status, first of all, to see what has been modified or not. Of course, doc1 and doc2. Now I want to add both documents. That is, so I'm just going to say Git. I want to stage it. Git add all of them. Okay, and that has been done. Git status, and it's going to be green now because it is staged. Okay, as you can see here, staged, modified. So now I'm going to I'm going to commit it. So git commit, and I'm going to call this my third commit, okay? Right. So git log dash dash one line, and as you can see here, we have 3 commits. We have the third commit, which is the current head, and I'll get to what this means in a minute. The second commit and the first commit. So let's say you made code changes in your code, and this recent commit is giving you issues, right? You fixed the bug, but you've deployed it and you've discovered it's giving you issues. How do you go back to a previous working version? Now this is really important. The codes you're seeing here are important, okay? So if I want to go back to the second commit, okay? Now recall what we have here. We have final doc1 and this new line hello, right? So if I come here and I want to go back to the second commit, all I have to do is type in git reset, okay, and type in that code you see there. I'm just going to copy it, okay, and paste it in, okay. And as you can see, I want to go back to the second commit, and I'm just going to hit enter, and as you can see, it's now, if I now type in git log one line dash dash one line, you're going to see it's now on second commit. So if I go back to my code now, and as you can see, it's now showing me that my code hello is what is an added code. So if I delete that, code is no longer modified, okay? And that's how you roll back changes within your code. So if I type in git status now, everything is working. Not okay. Now it tells me no file has been modified. So that's how you do. Before we proceed, just because you roll back changes doesn't mean you can't go back to what you done did, okay? So all you have to do is just remember the previous the code for the previous commit, which is here, okay, which is the third commit. All right, so all you have to do is type in git reset, the same process, and the code, and hit enter, okay. Now the files won't show up in your documents, okay, it won't show up, right? But if you do git reset, which means go back to the last commit, right, put my document in the last commit, it will do git reset dash dash head, dash dash hard, head hard, right? Oh, sorry, it's the other way around. Hard head. Yep. So git status. Now, if you go back into your document, the random things we added before are now back. We have successfully seen how to use Git to track our files. Now we need to explore the concept of branches. Recall when we did git log one line to see a list of our commits. We saw a weird line here that says head main. So I'll tackle what head means later, but let's look at main. Main is a branch, okay? And what is a branch? A branch is an independent line of development. So these are lines of development. As you can see, we have this main line, which we can see here, the main, all right? And these others are experimental. So typically in software development, we refrain from making changes directly to the main line. In order to, if you want to do experimental changes like bug fixes, adding features, or testing, we create a new branch so that we don't mess up our main code. And that's the reason why we need branch. Move on, let's talk about this head, what it is. So when you're in a line of development, like we are in main right now, and the latest commit is your head. Think of it as a snake, okay? Within the line of development, you have a snake. The tail will be your first commit, okay? And your head will be your latest commit. So whenever you add a new commit to that particular line of development, that particular branch, that new commit becomes your head. So how do we actually create a branch? It's really simple. You type in git branch and the name of your branch. So the name of your branch is typically a one word. So, but you can chain it in kebab style. So you can say an experimental feature like this, a feature. Let me just do this. A feature, or yeah, in extent, but let me just call this for now feature, okay? And just because you've created a branch doesn't mean you're in the branch. For you to go into the branch, all you have to do is type in git check out the branch name, which is feature, okay? And that's it. We're now in the feature branch. So we're in the branch, but everything looks the same. Now, how do we know we're actually in the branch? So if you're using Visual Studio Code, right, as we are right now, you will see down here, this git sign, it says feature, okay? That means that's the feature we're in. But if you want to know for sure, you come into your terminal, you type in git branch, okay? And the one with the asterisk is the branch you're currently on. As you can see here, the one in green and asterisk. The branch not only shows you your current branch, it also shows you all the branches within your repository. I'm just going to come here and create a new file. I'm going to call it sample.txt. And within this, I'm just going to say hello world. Okay. And right. We also have to, save it. Yep. Yeah, that is saved. Now recall, you have to also do the whole shebang with the main branch. The same is true. So we have to do git add. We have to add it from on track to track. And because we do this command, it is already staged, so we can already commit. Okay. I'm just gonna say first feature commit. Then bang. The log of our commits, we can see that the commit was successful to the feature branch. This commit that had no effect on the main branch. To demonstrate, we're going to go back to the main branch, and as you can see, we can still see this sample, but when I go into the main branch, this sample.txt is going to disappear. All right, so I'm just going to do checkout main. Okay, so as you can see here, it was deleted. Really deleted, it was never there in the first place. This sample.txt only exists in the feature branch of our Git. Let's say you were satisfied with what you've done in the feature branch. How do you make it come into the main branch? Like this, you fixed a particular feature, you've done an experimental software development, and it works out great. How do you bring it to the main branch? It's simple. So you go back, you come to your main branch, and I've confirmed to you that I'm in the main branch by doing git branch. Okay, and of course, as you can see, I'm in the main branch. All you have to do is type in git merge the branch name, which is feature. We want to merge feature with main. Okay. Now, as you can see, it was successful. If you go back into our project, we'll be able to see sample now. Sample.txt file, and it contains our hello world we wrote originally. All of our interaction with Git has been on the local machine, which is of no good, because if you wanted to collaborate, how do you actually do that? So what we've looked at prior to now is how to interact with Git local repository. For us to collaborate, we need something called an online or remote repository, and services like GitHub allow us to do just that. So the next step is to use GitHub to store our code. Now, I take it that you've signed up to GitHub, which is pretty simple. It's like sign up on an email or a Facebook account. Once you've signed up and signed in, there's this top plus button here. You're going to click it and click on new repository, all right? And we're going to name our repository software project, okay? Or any name you choose, but it has to be the same as, I'm just going to no spaces there. It has to be, relatively the same name as in software, the project in your local directory. Okay, and I'm going to leave everything as it is, and I'm going to click repository. Actually proceed, I would like to make some clarification. Right now I'm in Visual Studio Code, and I'll be using the Visual Studio Code terminal instead of this the terminal the default terminal on Mac. Okay, so before I was interacting with using this, but I'll no longer be needing it. And the reason is just to make everything more interactive. Now, for Windows users, you might have to continue using Git Bash. All right, I can't guarantee the terminal that comes with Visual Studio Code on Windows would work, but I'm sure of Linux. All right, so if you're on Linux, you can do that, and this would work. Straight, everything works as before. Let me just type in git status. All right, as you can see, nothing to commit through is clean. If I type in git branch, we can see all of our branches and the branch we're on. As you can see, we're on the main, and there's also the feature branch. Okay, so everything works as it is. It's just a different environment. Page, as you can see, the page has the repository has been set up. Right now, what we essentially want to do is send a copy of our local repository onto our remote repository. That's what we want to do. Now, the next step is to actually upload our Git, our local repository, to this online repository, also known as a remote repository. But before we can actually do that, using GitHub, this particular service, you need to add your security, like signing in to GitHub, to let GitHub know that this computer you are the one doing the commit. All right. For you to do that, it requires a special process. We used to be able to just log in and sign in like Facebook, but now it requires adding a special SSH key that is more secure. But there's a process to that, and I'll link that in the description. Very good. Now I assume you've set up your SSH key and everything is good to go. Now, it's telling us that if we want to upload our documents to Git, we need to do a couple of things, right? So we're going to use this documentation and not this one, because we've already done all of this. We've covered all of this before, okay? So we're going to use this documentation. We already have an existing project. So the first thing we need to do is to add the link of where we want to upload this local Git repository, where we want to upload it to. All right, so this is what this means. It's telling we're giving it a remote direction. So I'm just gonna copy and paste that in here. Right, so that is done. Then the next up, I'm just gonna do branch M main, which is just to well, this is just to say our branch is master. The master branch, or the main branch, is the main branch. Okay, so we don't need it. Now this is what we need. We're saying push everything, push our code to the main branch. So this, we're going to copy this, we're going to paste, and once that's done, I'll refresh my page and you'll be able to see my code right here. Of course, as you can see, now everything within Git, okay, that we've done throughout Git can now be seen here. All right, all of our commits, everything, first commit, second commit, first feature, and then we can also see the other branches we have. Oh, before we explore why we couldn't see the feature branch in our remote repository, let's go through what we just typed in the command line one by one. The first line of code here says git remote add origin this address, this GitHub address. This is our online GitHub address. What this basically does is give Git the URL of the remote repository, such that when we push, okay, when we push to an online remote repository, it knows where to go. The final command we have here is git push -u origin main. And what this does is it grabs a code from whatever branch you're on and puts it on the main branch of the remote repository. Let me repeat that again. It grabs the code for whatever branch we're on and puts it on the main branch of our remote repository. So if I'm on my main branch and I run this code, the Git will capture the code from my main branch and push it to the main branch of the remote repository. Now, every time we want to push to the main branch of the remote repository, we have to run this code. But because we've added this U flag right here, we don't need to do that anymore. We don't need to write this full command. Anytime we want to push to the the main channel. So what this does is subsequent push, all we have to do is just write git push. But for the first time, we have to just do git all of this command. So why didn't we see feature from the feature branch on remote repository? The reason is simple. We've only pushed from main branch of the main branch of the main branch of the local repository to the main branch of the remote repository, and this U flag sets up a connection between them. So in order for us to see our feature branch, we have to also repeat the same process for the feature branch. In order for us to see the feature branch on our online repository, we have to repeat the same process we did for main to our feature branch. So I'm going to come check out my feature branch. Okay, check out. Right, and then so I'm just gonna do this as well. I'm just gonna do git push. Okay, git push -u origin feature. Okay, and that is done. So if we go back here and refresh, we will be able to see our branch feature. As you can see here, now it's here. Right, so as you can see, we've successfully committed our feature to our remote repository. But recall that we've merged feature with the main branch, right? So in a good workflow, we typically delete the features, the branches that have been merged to the main branch. So as you can see, when I ran git log --1 line, as you can see, this is proof that it has been merged. So when it comes to head, as you can see, both main and feature, the head point to the same thing. Okay, so in order to delete a branch that we no longer need, we write git git. Right, first of all, we need to check out. We need to check out to another branch because we can't delete a branch that we're currently in. So we're going to check out to main, okay, and then we're going to do git d git branch d and the name of the branch, which is feature. Okay, that will delete it locally. Now we need to also delete it on the remote branch, and to do that we do git push, okay, dash dash delete and the name of the branch, which is feature. Right, I ran that a bit wrong, so it should be git push. You have to also mention the origin. The origin is just a code word for that address. All right, where are we pushing to? So origin push delete feature. So it will delete that branch. And if we go back to our, delete it. So if we go back to our remote repository and reload, of course you can see it's no longer found because it has been deleted. So if I go back to my main repository, the main page, and I check out branches, it's gone, deleted. So that's how you do it. Alrighty, so let's create a new branch, and let's assume this branch is trying to fix some error or do some experimental work. So you recall the procedure, you create a branch, then you check out into it. So there's a neat shortcut you can use to do all of that without having to do those two steps. Check out, and you write git b and the name of the branch. I'm going to call it ex1. All right, it created the branch and it checked into it. So I'm just going to create a new I'm just going to call it ex1 file.txt, ex1.txt. There's no need for file, and I'm going to say hello world, the standard. Save it. Back in my terminal, you recall git add dot git commit dash m ex1 branch. Okay, and right, so now it's time to push. Right, recall we're doing git push dash u origin ex1, right? That's the name of our branch. So we come back to our repository, right? So this has been automatically updated. So let me refresh, and we now have this branch. Okay, now this branch has not been merged, so it is there. As you can see, we have our ex1 down here. Right, so that is done. For us to actually submit for us to actually merge from this ex1 branch to the main branch, we have to do something known as a pull request. What is a pull request? A pull request is basically saying, you saying, here, I've made some changes, please review it. That's it. Okay, so what you need to do is go into the account which you've pushed your code to right, and go into the channel of the branch which you have done, and of course there's this big green button here, but if you don't see it, switch to the branch which is ex1. Okay, and then you'll be told, oh, this is commit, and do you want to create a pull request? So I'm just going to say compare and create commit and pull request. Okay, and I'm going to call this ex1. Please, I'm going to write here, please accept my changes. Okay, create a pull request. Done. Now that the pull request has been created, now the owner or the person managing, because when you're working in a team, there's usually someone who's managing the main branch. Okay, when you create a pull request, your team would have set up who's managing it. When you create a pull request, that request goes to whoever is managing that, and they'll get an alert to say, okay, this person made some changes and has made a request to merge his or her branch to the main branch. Now they'll have to come here and click on manage merge pull request, and they will go through your code, right? They'll go through your code, and they'll go through your commits and see everything is all right. Okay, and then you say, yeah, merge pull request, or if they have any comments or things, they will write it here and write a comment, okay, fix it, then you fix it again, then you send another pull request. But let's say for the sake of argument, this is a good thing, you just confirm merge request, and we're done. This is now been merged to the main branch. So if we go back into our code and we go into main. Now we can see ex1, all right? Ex1 branch, okay? While ex1 is still in existence. While the ex1 branch has been merged to the main branch in the remote repository, the local branch has no idea this has gone on. For us to see the changes, we have to pull in all of our data from the remote repository. So for us to do that, first of all, I'll go back to my main branch. Okay. Then what I'll now do is type in the following command, git pull. And that will pull the latest changes from the data from the remote repository. And as you can see, we now have ex1.txt. Now let's recall that it's good practice to always delete a branch that has already been merged to the main branch. So that's exactly what we're going to do. Remember the code for deleting? So we're deleting in two places now. We're deleting on our remote repository and we're deleting on our local repository. So we're deleting on our local repository first, and the command is git branch -d and the name of the branch ex1. Right. So before you actually run this command, make sure you have checked into your main branch or a branch that is not the branch you want to delete. Right. So right now I'm in the main branch, as you can see here. So I'm going to execute this. All right. It tells me branch ex1 has been deleted. And I'm going to repeat the same process for the online repository or the remote repository. And the command for that is git push --delete. Okay. And origin, and we say ex1. Right, it tells me that has been successfully deleted. So if I come back into my repository, as you can see right now, I'm yet to refresh, but it's saying 2 branches. But if I refresh, it will only be 1 branch, as you can see. Now we're going to be looking at git merge conflict. Okay. Now let's say, because in practice, when you're using Git or when you're in the software development team and you're working, it's not you won't be the individual contributor. You'll be working in the team. And what happens is sometimes there is a conflict between what you're doing and what the other person is also doing. Conflict in the sense that you're both working in the same file. So one person has updated the file before you, and so yeah, let me demonstrate. So I'm going to open my Git, right? And we're in our project. Let me create a new okay, let's do this locally. Let's recall the process. Git checkout -b new, let's call this new feature. Okay, all right, and then let's create a new file in our new feature branch. Right, so recall this command, it creates a new branch and switches into it. Okay, that's when this new feature branch. So we're going to create a new feature.txt, new feature.txt. Yep, and let's just write new feature 1. Okay, and this is really important. And remember the procedure, git add before you commit, then git commit -m first commit. Okay, then we do git push, remember, -u origin, then the name of the branch we want to push to in our remote repository, new feature. Okay, that's done. Then now it's done. So if I go back here and I refresh, we now have 2 branches. So if I go into that main new feature branch, okay, and let's say I add a new line in this code here in this new feature, and I say new feature 2, right? And I save it. Added new feature 2. This I'm just simulating someone, another collaborator who's made changes to this file that you're also working on. Okay, so but let's say you were tasked with working on new feature 3, and recall the new feature 2 that is here is not in your code. You are just working on new feature 3. Now if I try to add this, first of all, let me clear my terminal. So if I try to, let me add it, let me stage it for committing, and let me say git commit -m, and let me say added feature 3. Okay, now let me push it, git push, that is push to my remote channel. Oh wait, something, I didn't save it, so I have to do this again. Git add, git commit added feature 3. Okay, nice. So now if I try to push this, I'll be told there's a merge conflict. Okay, it says my push was rejected. Let me bring this up. My push was rejected. Failed to push some reference to GitHub. Objects were rejected because remote contains work you do not have locally. So it means my branch that I was working on has been updated. Okay, this you would encounter this when you're working in a team, right? So what do you need to do is git fetch first of all. Okay, so that would catch up to date with what is on the remote repository. So now if you do git status to tell you, oh, your branch is one behind, oh, this message, your branch have diverged, and don't worry about it. It means somebody has done work. So what you need to do is write git merge. Okay, and now this is the beauty of Visual Studio Code, right? So whatever IDE you're using, you would have something like this, and you're merging. When you say merge, you're saying, like, you're saying mix, bring them together. Let me know what to keep and let me know what to delete. All right, that's what you're saying. But in this case, we want to keep both, so we're going to say accept both changes. Okay, now feature 2 is down here, feature 3 is up here. All right, which we're okay with. Okay, and what we're just going to do is say git add again. Well, first of all, I'm going to save this, then you're going to add it, then git commit, and I'm going to write a message merged with added feature 2. Okay, then we're going to push it. Now let's look at our code. Let's refresh. Now, yeah, as you can see, everything is in order. So that's how you deal with that. So if you now look at the contributor, you see that the feature 2 is here, feature 3 is also here, but the merged one is also here. All right, so there was a divergence, but you converged it and you merged. So that's how you deal with merge conflict. So far we've seen how to use Git with a new project, but in most cases you're going to work with Git with an existing project, and there are 2 types of projects you can work on using Git, broadly speaking. Of course, if you're doing, number 1 is private. Okay, private businesses. So private businesses, their code is going to be code source, so they're going to have to give you permission in order for you to interact with it. All right, the second one is open source. Open source means the code is available on a remote repository hosting website like GitHub, and you're going to just go freely there and see it. So far we've used Git with a new project. How about we want to use it with an existing project, like most cases or most scenarios you will use it with? Okay, so to do that, there are actually 2 scenarios if you want to use an existing project. Number 1 is you're contributing to what's known as a closed source project. Okay, and this or an open source project. So a closed source project is typically a business or an organization's code that is not publicly available for obvious reasons, so you have to contribute to that. Then the open source is a software that are written by the general population of the software developers and contributed to by different people. So first of all, we're going to be looking at contributing to open source. So I have opened this URL. Let me see. This is an open source project. Okay, although it says it's just it's not really a code. It's just to get a big sweat into how the process works. So this is like an open source project, and we'll see what we do here. Well, how do you contribute to this project? Okay, the first thing you need to do is fork this project, and what this fork does is it copies this exact project and puts it on your own profile, your own GitHub profile, where you can work on it. And when you're done working on it, you now send a merge request or a pull request. We've covered that before. And what that does is, hey, I've contributed to it. Please accept my changes. That's what that means. So let's go ahead and create a fork. I'm going to come here and create a fork. And of course, I'm going to leave this as is. So if, for example, you have many profiles on GitHub, select the appropriate one and repository name. And yeah, if you want, you can copy all the branches within this particular project, but it's not all the branches, but it's not ideal. It's just better to copy the main. Okay, so that's what I'm going to do, and leave this and create a fork. So in a minute, what you're going to see is it's going to add this to my project. As you can see now, it's now on my profile. Well, once it's done, it's going to be on my profile. But what you need to do about any open source project is usually in the readme.md file. So we're going to go ahead and open that. All right. And, it's basically telling us what to do. Clone the repository. We've done that. Then we need to create a branch. Okay. Right. So let's create a branch and switch into it. Okay. And before I move on, let me open this folder because this is our previous product. So I'm just going to do. To actually work on this code, we have to download it to our local machine. And to do that, we go through a process known as cloning. Cloning is simply download it to my computer. Okay. And it also downloads the Git. So you come here and click on code and click on this URL. Don't click on download. You click on this one. All right. Then we'll come into our code editor, and what we need to do is we need to download it. Okay, but look, if you look on our terminal, this is the directory we are in. We're in software project directory. This is where we are. Let me show you. This is where we are. Okay, but you want to create another you want to give it another file. It will download the entire folder, all right? But what I'll do is I'll create a new folder for my open source contribution. I'm just saying open source, okay? Okay. Now I'm going to navigate to this folder from my terminal. So what I'm going to do is I'm going to write cd, right? And I'm going to drag in this folder into my terminal, and it will automatically give me the path to that. So yeah, I hit enter. Now it has navigated to this folder. As you can see, the name has changed. So let me clear this up so you can, as you can see, it's now in this folder. So what I'll now write is, so terminal is no longer interacting with this folder here, software project. It's now interacting with open source. Okay, and this open source will just hold all of my open source projects. So I'm going to write git clone, and I'm going to paste in the URL I copied before, and I click on enter. So it's going to download it. So yep, that's done. Now if I open my folder, let me show 1 minute. Yep, if I open my open source, as you can see, it has been downloaded. So yeah, we have to navigate into this downloaded folder, first contributions. Okay, I'm going to say cd first contributions. Okay, ls. So of course, these are our files within the directory. As you can see, it correlates. So what do we need to do in this project? Open file, new open folder, and of course it's going to be my open source. No, yeah, this is going to be this one. Okay, open. Right, so we've got our code here. So yeah, I'm going to reopen my terminal. So new terminal. Essentially what want to happen is to write our name in this list. Okay, as you can see, so all we have to do is write our name. So you can read the readme.md here to get more idea, but I'm just going to go ahead and execute it. So first off, we have to create a branch for us to make our own changes. Okay, it's very important. Git checkout -b add Like, that's my name. And in this branch, I want to come here and add my own name. Yep. So this will be Like, then Like. So after we're done, remember the procedure: git add dot git commit. And the recommended way of writing our commit was to added this. So just gonna put that in there. add up where add up where yep. Oh yeah, sorry. Git commit dash m. Forgot that. Right, so everything is done. Then I git push u origin add dash okwe leke. Okay. Oh, I typed that wrong. Origin or yep. So I'm gonna come back into my own Git profile. Yep, I'm gonna go back. Just gonna come back. Yep, I'm gonna refresh. Now I'm gonna see my branch. Now that I've made my wait, let me go to this branch. Now I've made my wait a minute, view, wait. Discovered I didn't save my document, so let's redo it. And for yeah, well, instead of this link up, let me write my full name. Oh, that should do. Okay, and yeah, let's save it this time and run our code. Git add dot git commit dash m. Let me just find the original one. And yep, just type in that. So add MEO to contributors list. And that's done. Of course, yep, that's done. So now I have to push. Yep. Now if we go back to our branch, let me refresh this. Now you can see the changes have been added. Okay. Now an interesting thing has happened, right? An interesting thing has happened. Since the last time I pulled this, cloned this repository, there have been commits, right? So what I need to do is not worry too much about that. All I have to do is create a pull request. It's up to the owner of the project to sort out the merging conflict. So please add me. So I'm just going to write a message to the maintainer. Please add me to the contributors list. And that's it. You create a pull request. Recall, pull request is basically saying, I've made this change. Please review and accept it. So hopefully soon my name gets added to the list. So right now the owner of the project would get an information about from me about this project. So here was my pull request, and I just got literally an alert that yeah, my request has been merged. It has been merged to the main. So that is that. As you can see the message. And if we go down to, if you open the readme.md file, you can see my name here. All right. And if I click on it to take you to my profile. So yeah, that's nice. That's how you work within open source. Yeah, I mean, this is like a really summary, but most open source projects, they have you have to read their readme file. For sometimes they might have the way they do certain things, but the idea is generally the same. They might have naming conventions or things. So yeah, just check about that. So right, so remember that once a branch has been merged, it's good practice to always delete it. So I'm just gonna do git I'm going to do it locally first before I do it remotely. And is git branch d. Okay, so first of all, I need to check out. I need to check out from this branch into main because it won't delete a branch that is currently in. So I'm just gonna get checkout. Git checkout and git switch. Let me switch are the same thing, all right? Switch to main, and I'm just gonna do git delete branch okay, all right? And it's telling me that the branch has been deleted. Then next, I'm gonna push origin, push delete origin. Yes, it was supposed to be a double dash. Right, so if we go back to our my fork, you will no longer see the where's my fork? Yep, this is my fork. As you can see, it's now one branch. Okay, so that's it. So ever since I added my name, 4 other people have done, there have been 4 other commits. So if I sync it now, update. So in a way, this fork is still connected to the main branch. All right, so that's why we had to create a branch, and now when working with this fork, okay, so it's still connected. So if you so finally, before we leave this open source thing, let's do git pull. And what git pull does is it updates my current my project. It pulls from the server and dumps it on right here. So git pull. Okay, as you can see, the names have been added. Okay, and this is my name down here, showing me that there are 4 additions to this file and 1 deletion. So anyways, that's it. Yeah, I wanted to show you something. Now let's look at the log of this file, of this project. And as you can see, all the commits. Yep. So all the history of everything going on within this pull. There's quite a lot of history here, so it can be good for knowing what's happening within the code base. Contributing as when you're working in a private company, the code is not open source, closed source, right? So yeah, obviously the code for that one you won't be able to fork, right? So for example, when we're right, so when we're creating a repository the other time, you see we had the option of public or private. When it's private, your organization would have to add you as a team member on their repository. All right, so you have to set you up first. They have to set you up, and after they are done setting you up, then you now do git. Open my terminal. Git clone whatever the URL here says. Git clone something XYZ. Then you'll be able to now bring it down to your machine. Now, without getting too technical or going into the project management side of things, there are 2 main strategies used by organizations to manage Git workflow. Number 1 is what we've been looking at. I didn't give it a name before, and it's the GitHub flow. We've been using the GitHub flow. Now, GitHub flow is an iteration of Git flow. Git flow is more complex. So one moment. Example of what GitHub flow looks like. So we have the main branch here, all right? Then you have an issue, all right, or a problem, a bug, or a feature you know to add. You create a branch. You submit a pull request that is, hey, I've made these changes. Please accept it, right? And if there's a merge conflict, you talk to your team members about, oh, which one should we keep? Which one should we delete? Or we should keep both, right? You talk to your team members. Then simple. Once that conflict, if there's a merge conflict, and if that has been resolved, they merge back into the main branch. So for example, look at this open source project, right? You say, oh, you see this project, oh, somebody has detailed the issue, then you copy you clone it, you fix it, you merge. Simple. That's the GitHub flow, and this is typically used in many organizations. It's the easiest one to know. All right, it's used by companies like Facebook, many companies. Okay, And here is the Git flow, right? Git flow was a predecessor to GitHub flow, right? It was created a long time ago. And in this code, in this type of flow, right? I promise not to go into too much project management side, but in this flow, we have like 5 different branches, okay? So, you know, it's a mess really. That's why they came up with GitHub flow. But um what's going on here is that if you want to work, you are going to be, if you want to fix a feature, if you want to add a feature, you are going to be branching from the develop branch. All right, you're not going to be working from the main branch, which is master, main or master. It's the same. So if you want to add feature or do anything, you have to branch from the develop branch. And if you want to maybe fix something is quickly broken in your app, and you want to fix it, you create you you branch from the the hot fix channel. So it's complicated, right? So it's an outdated way of doing things, but it's still used by some institutions like banking institutions, because this type of flow ensures for rigorous. As you can see here, there's very little commit to the main branch, because they want to ensure that whatever is on the main branch is stable as possible. So it's typically used in like legacy banks. So if I were you, I wouldn't really worry too much about knowing this. I would master the the GitHub flow. Then when this get when if you master that one, then you can master this. At the end of the day, it's up to your organization to tell you which kind of Git flow you guys are going to be using. But yeah, so if you want to improve your first of all, thank you for staying to the end. All right, it's been a wild ride going through Git. But if you want to improve your Git skills and things like that, look at contributing to open source. All right, you can even get paid doing it. Look at Google Summer of Code, which is coming up soon. It comes up every year. So look at, and you contribute to open source, and cheers, happy learning.